I'm Luke, and with Spencer, we took a look at a 2007 Dodge Grand Caravan's fuel injectors and had the opportunity to diagnose a real problem on the vehicle. We started off by trying to get a good understanding of the vehicle's fuel injector operation through all data and by looking at the wiring diagrams. By looking at the wiring schematic, we were able to see that each injector had the same power side circuit. However, since fuel injectors are ground controlled, each also had their own path to ground and was controlled by the ECM. Also learned through all data was that the engine used multi-port injection systems. To actually get to the fuel injectors and be able to test them for voltage, we first had to take off the intake manifold. After removing the intake manifold, we then tested each sensor for negative potential. All sensors turned out to be good and had battery voltage readings. After testing negative potential of the sensors, we then hooked them up to picoscope to be able to see the waveform they created. The first injector we tested was injector number 2. Injector number 2's waveform looked normal, and so we decided to test it at different RPMs. We tested the fuel injector up to 2000 RPM. As RPM increased, the frequency that the injectors were open also increased. Before we went on to test the next fuel injector, we noticed the engine was running a little funny, and when we connected the scan tool to the OBD2 port, we were able to see that cylinder number 5 was misfiring. We decided to hook up a picoscope to injector number 5. After hooking up picoscope to injector number 5, we then started the car to see the wave. The wave did not look anything like it was supposed to, so we knew there was a problem with that injector. We wanted to see just how off it was from a good injector wave, so we hooked up injector number 2 again to the same pico. As you can see, there's a pretty big difference in waves. We wanted to finish diagnosing this problem, but unfortunately class time was up. We came back the next day, but had to start all over again with taking off the intake manifold. After removing the intake manifold, we were ready to get back to work on diagnosing the misfire issue on injector number 5. We again checked power and ground to injector number 5, which again gave us good readings. However, while we were doing that, we noticed that injector number 6 looked to have a bad or broken connector on it. Again, we checked power and ground, but on injector number 6 this time to see if maybe the scan tool was labeling the wrong injector misfire. However, the readings were once again good. Before we went any further into the diagnosis, we wanted to be absolutely certain that the injector we thought was number 5 was actually injector number 5. We did this by removing the spark plug cable and putting a test light on the distributor and grounding it out to create an internal misfire. If we were wrong about it being injector number 5, the scan tool would show that a different cylinder was having a misfire. And if we were right, there would be no change in codes thrown. The test ended up confirming that we were right. It was injector number 5. We then went ahead and tested resistance through the entire injector number 5 circuit. By doing that, we found that there was an open somewhere in the circuit. From previous testing, we knew that the connection from power was good, so we decided to connect it from the PCM to the connector, and we only got 0.2 ohms. We knew that was good, so then we tested from the fault box to connector 102 and got OL. This meant that it had to be a problem with the box. To fix it, we spliced the wires from the box and the orange wire from the PCM and started it up. We checked the scan tool for misfires and fuel injector faults, and none were found.